In the last session, we listened to what the outreach interns have to share. Now, let's see what our GSOC interns have to share about their projects and experience.
This is a talk about my Google Summer of Code project with the Freedom Box Foundation. I worked on an email server for advanced single-board computers. This is an email server that you can run on a Raspberry Pi, on a BeagleBone, an OX board. It aims to be low on resource usage. I recommend having 1 GB of spare RAM for the email server, but in reality it uses less than that. It's powered by 100% Debian packages installed from backports, so they're stable and reasonably up-to-date. It contains a web service that does most of the configuration. Traditionally, configuration can be an error-prone process. With FreedomBox, you don't have to be an email setting expert because we worked out the most difficult situations for you. There is a user manual in case of trouble. To set up an email account, open your Thunderbird, type in your username and FreedomBox email address. Click Continue. Thunderbird has found the configuration. We implemented a few usability features, including Thunderbird autoconfig, subaddressing. This will help you with spam filtering. We also have a web UI for managing email aliases. We labeled special use mailboxes. We also set up auto-expunge for the junk and trash mailboxes every 30 days. Let me introduce you to the data flow in the email server. When an incoming mail is submitted from one of the 3 opened ports managed by SMTPD, the rspmd component does base analysis, SMPF checks, DKIM checks. It also adds special headers for a spam filter at a later stage. The SMTPD queries the local respin table. If that is successful, the cleanup process does sanitization and header checks. The queue manager acts as a client to the LMTP interface of DovCot. It talks DovCot via the local mail transport protocol. The DovCot queries the LDAP database for user information. It runs sieve filters to put the mail into a designated folder, and it saves the mail into the user's mail directory as specified by LDAP. The email server implemented a few privacy enhancements, including header privacy and server security. We have header privacy for inbound mail. The email headers in your mailbox will not reveal the alias that you are using. This is done by turning on DovCot privacy features. In the demo, we have 2 mail hosts. Host 2 is a FreedomBox. The Dave user has 2 mail aliases, Dave and Contact. The admin user has 2 aliases, admin and privacy. Pay close attention to how the headers are handled in the mailboxes. Here I am sending an email from my FreedomBox host to the Debian host. The Debian host has the default DovCot configuration. By viewing the headers of contact at host1.test.example, we can see the email is delivered to Dave at host1.test.example. This reviews the real user login. If you forward the email as an attachment, this can be a privacy risk. From the Debian host, I am sending an email to the FreedomBox. By viewing the headers, you do not find any information about the login behind the privacy alias. We also have outbound privacy. The outbound headers are checked, and sensitive user information are deleted. I'm sending an email from my FreedomBox to the Dave at host1.test.example. In the sent folder, Thunderbird added a user agent header to the email. In host1's inbox, we did not see a user agent header. This shows that FreedomBox cleans those headers before delivering the email to another host. In stock postfix, it's not trivial to distinguish outbound mails from inbound mails. This is because an authenticated user may submit from any of the 3 ports, and header checks are applied to all mails, not just outbound mails. Nevertheless, I worked out the correct information flow that allowed me to implement an egress filter. This is done by using the MOTA protocol and a separate SMTP-D process. When an outbound mail is submitted via any of the 3 open ports, the policy server checks the user's authorization to use that email address. The mail is run through RSpamD. RSpamD knows the user is logged in, so it adds a special header to the email. The cleanup process does a special MOTA header check. When it sees the special header, it tells the queue manager to change transport. The queue manager obeys the cleanup daemon's directions, so it routes the email to the FreedomBox egress filter running on port 10025. The email is re-injected into the queue. The queue manager delivers the cleaned email to the internet via SMTP client. We also have server security, in particular an anti-probing strategy. In postfix plus LMTP setup, mails to system users will be bounced. This is because postfix actually thinks the email is deliverable, but Dovecot refuses to deliver it. This generates a non-delivery notification that leaks information about the host's user table. We do not want that in FreedomBox. So in FreedomBox, mails to system users will be rejected immediately at the SMTP connection level. The etc password entry has been removed from the local recipient table. The implementation detail is like this. The local recipient table is made of 3 components. The LDAP database, which does not contain information about any system user. The system's alias database, which allows the administrator to overwrite any aliases. We also have the plim's own alias database. The rationale being, some packages are known to modify etc aliases, causing information leak about what packages are installed on the host. The system admin may also remove the system's alias table from the lookup order. I would also want to focus on the technical overview when implementing code for the server. I used service orientation. It has standardized operations and customized resources. The standardized operations has idempotency requirements. When programming the API, I focus on atomicity, consistency, isolation, and durability, so that there are no partial writes to config files. I use thread and file-based locks so that all processes can see the lock, and no process can interfere with a single process's operation. Although some areas still need work, some large email providers implemented their own restrictive spam filtering policies that will block out legitimate emails. In this case, it makes sense to interoperate with an email provider to get around the restrictive filters. I would implement this by using a caret path syntax that resembles UCP. I did not use the exclamation mark because it can mess with parsing. The relay caret prefix tells FreedomBox to use its smart relay service. The data flow is complete, but there's no actual routing yet. We're working on tighter Let's Encrypt integration and testing, decoupling of the standard policy server. Thank you for your attention.
Hi, I'm Prateek. My summer of code project is Android SDK tools in Debian. My mentors are Hans-Christoph Steiner, Chirayu Desai, Andrew Shadura, and Phil Morrell. The Android Software Development Kit is a collection of tools that can be broadly classified into 2 categories: platform tools and build tools. Platform tools are used to interact with the platform, which can be either an emulator running Android or a real Android device. Build tools, on the other hand, are concerned with the build of apps, that is, the creation of APK files, which is Android's format for its app. ADB, or the Android Debugging Bridge, is a tool that can be used to debug apps while we are developing them. As such, ADB allows us to copy files or other app data from or to the platform. We can even open a command line shell on the device using ADB, which can be used to, say, get a list of the running processes or have a look at the logs that the Android system has collected from various apps. The Android device can be booted into one of the various modes, such as recovery mode or the fast boot mode, which is where the next command, fast boot, can work. ADB is often used in conjunction with, let's say, an IDE such as Android Studio, where it is used as a bridge between the development machine and the Android platform, where it can be used to install apps created using the IDE quickly onto the device and test it out. Fastboot is a less commonly used command that is used to interact with the storage partitions mainly that are there on the device. It can also be used to execute certain manufacturer-specific commands. Now, in order to make changes to partitions, the bootloader of that device needs to be unlocked, which can also be achieved using this tool. The main use case for fastboot is to replace the operating system on the device with a custom one perhaps, or maybe dump or delete other partitions such as the data or cache partitions. Moving on to build tools, there are several tools in that category, but the most important ones are perhaps the following. AAPT, short for Android Asset Packaging Tool, is used to modify app files or APK files, which are essentially zip files with a specific internal arrangement of files. It can be used to modify the asset files of an app, package, or just display all sorts of information regarding them. DX, short for Dalvik Execute, is a tool that is used to convert Java class files into DEX files, which is the bytecode format for internal Java runtime that Android has. Now, the runtime that processes these used to be Dalvik, but as of now, it has been replaced by ART, short for Android Runtime. Zipalign is another tool that deals with the zip-like archive files. It is mainly used to optimize or align APK files so that the Android installer can quickly access the files that it needs in the requisite order. If the APK or zip file had not been aligned, the files would have to be stored into the archive in a random order, slowing down the installation of that app. Let's have a quick look at the ADB and fastboot commands interacting with a physical device that is connected to my computer via USB cable. After connecting my device to my computer via USB cable, I can list out its ID over here. So that's the ID of my device. If you're connecting your device for the first time, then it will display a dialog on the device asking you to authorize the computer to connect to it. I have mine authorized. So let's just pull a file from the device onto a system. So it works. As I said, we can also open a shell on the device using which we can execute commands directly on the device. Here's the Android's internal logcat, which just collects all the logs from the apps. There's a lot of logs from all the apps that are running on the system, and these get collected over here, which we can see. It keeps scrolling. It's a continuous thing, so we'll just shut it off here. After that, let's try installing an app. I have an app here which I'll try installing to the device using ADB, and that says success, which means here I can see the app on my device. So using this, we can quickly deploy all apps which might be in a work in progress condition. So if we have an ID and we quickly want to test it out on a real device, then we can use this method to use ADB as the bridge, that is, between our computer and the device to just install apps. Using ADB, we can also reboot the device into specific phases, such as, let's say, boot into the bootloader phase, where it is the device will be ready for the fastboot command. So let's just do that. Now here I can see my device is rebooted into fastboot mode. So I'll just Yeah, so again, it listed out the exact same ID of my device that ADB listed. Now, I won't be executing any more fastboot commands on my device because I really cannot modify any partitions right now for testing purposes. So that concludes our short demo. Moving on to how these tools are packaged in Debian. Uh, for ease of updating the Debian repositories that are used to package these tools, it was decided to break the source upgrades into three phases. Phase 1, there are tightly coupled dependencies between the different libraries that these tools depend on. So instead of building them from separate repositories, the upstream sources were all put into a single repository so that they can be used to upgrade together. This approach also follows the upstream layout as closely as possible, while upstream uses a custom built system known as Zoom. They are in the process of moving away from it to perhaps something known as Bazel. Since we were already using new makefiles as the build system for our Debian repository, we decided to stick to that. This phase 1 of the upgrade took 2 months to complete, April and May. Phase 2, the phase 1 sources came from the Android set of upstream tags, but starting with Android 10 source releases, Platform Tools has its own dedicated set of Platform Tools tags. Now, in order to have not too many source level changes to sort out, the upgrade to the latest version, that is version 31, was broken down into an intermediate upgrade to version 29, followed by the final jump to version 31. This phase 2 of the upgrade process was completed in July 2021. Moving on to phase 3, which has been ongoing since August 1st. The last and ongoing phase of this upgrade is that jump from version 29 to 31, which in turn corresponds to Android 12 source release. Due to phase 2, the build rules for the sources are mostly already in order for the upgrade. So this phase is as simple as updating the source list with the new sources. For the last few years, Google has been releasing the latest Android sources in September of each year. So the Android 13 source release should happen in September 2021, which is when we will update the source list again to bring the Debian repositories in line with the latest sources. What this project means for Android developers and end users using Debian is that they can use the latest Android SDK tools by simply installing the relevant packages using the apt package manager instead of having to download and install the zip file binary releases that Google provides. Using this package manager approach also ensures that users can easily update these tools without having to install a full IDE, such as Android Studio, to do it for them. I would like to thank my mentors for all the guidance and support that they have provided. They were really friendly and always ready to provide tips to assist in my work. I learned a lot about different build systems such as make and gradle, as well as a lot of useful functions of the git command beyond the basics. This project provided a lot of opportunities for me to automate text-based jobs, such as making those build files or perhaps extracting the source lists from the Zoom build system, for which I used my own small scripts and macros. These helped to speed up the work on this rather large project while reducing the scope for errors. I did have a lot of fun working on this summer project, so thanks for watching.
Hi, my name is Leandro Doctors, and I'm the GSOC intern working with the Debian Closure team during 2021. My project, Closure Build Tools, aims to package into Debian some core upstream Closure build tools and libraries. More specifically, the Tools Debs Alpha library and parts of the official Closure CLI build tools, such as CLJ. My mentor is Louis-Philippe Veronneau, and my co-mentor is Utkarsh Gupta. I'm working with a small yet very warm team. The current incarnation of the Debian Closure team exists thanks to the hard work of 3 people. Elana Hashman, aka the Closure Necromancer, revived the team around 3 years ago. Later on, the team gained the invaluable presence of Louis-Philippe Veronneau and Utkarsh Gupta, my mentor and co-mentor respectively. Together, these three musketeers have maintained the team alive, allowing us, Debian users, to enjoy Clojure. Why this project? On the one side, if you're a Clojure lover like me, you may have noticed that the Clojure experience in Debian is, as of mid-2021, well, still quite limited. Additionally, this project aligns with my own background in free software community building and my research interest in peer production. When I mention how limited today's Clojure experience in Debian is, I can see two reasons for this, deeply intertwined. The first one is that there currently aren't many Clojure-specific packaging tools in Debian, such as a Clojure Debian helper. The second reason, for which we only currently have a suboptimal Clojure experience in Debian, and probably the root of the previous one, is that many core build tools and libraries for the language have not simply been packaged yet. My project aims to attack that seemingly root cause. As I said, another reason for me choosing this project is my own experience with free software. Years ago, I got started and led for some time what could be called probably the first free software community experience in my hometown of San Juan, Argentina. That initial involvement in free software communities evolved into a first PhD attempt in what is now known as the field of peer production, a subject that has lived within me as a research interest I carry on during my day job at the university. Being a Clojure fan, it felt only logical combining all those interests somehow. And this project seemed like the ideal combination. The goal of this project is to provide Clojure Debian users with some of the latest advanced build tools and libraries the upstream Clojure developers have been lately working on. This includes Tools Debs Alpha, a library for dependency graph resolution and class path building, and the CLI tool CLJ for REPL interaction. If time permits, I will also improve the quality of both new and existing Clojure packages and the overall Debian Clojure packaging process. During the first part of my project, I mainly worked on learning the basics of Debian packaging and got my first package uploaded. I have to thank Louis-Philippe, Utkarsh, and Elana for their immense patience during that part, as it took me quite some work grasping the basics of Debian packaging. For me, it was indeed a steep curve. If I learned one thing during that term, is that packaging, although easy to be underestimated, is by no means a trivial process. During the second part of my project, I am currently working on my last packages. I should have some time left so I can start working on the opportunities for improvement already identified by the Debian Clojure team, such as writing linting tags to make Clojure packaging in Debian more robust, working towards the automation of Clojure unit tests in AutoPKG-test via AutoDebSite, or updating older Clojure packages not built using Leiningen or CLJ. Technically speaking, if I have learned one thing during these weeks, as I said before, is that packaging, although easy to be underestimated, is by no means a trivial process. As many Debian developers surely know, the onboarding process can take some time. Plus, what is easy for some people can be difficult for others. In my case, this was quite evident. Whereas I can speak several languages and learning new ones takes me little effort, grasping the basics of packaging took me literally blood, sweat, and tears. Indeed, the packaging learning curve was quite steep for me. That being said, I did learn a thing or two about packaging. So, if I manage to get there, I'm sure many others can. It may take them more or less time than what it took me, but learning at least the basics of packaging is an achievable goal. Technical skill learning aside, I value very highly the non-technical skills I have so far improved during this project. For instance, I also learned that it can take some time to adapt to real-time online communication. Before this project, remote working meant either exchanging emails or getting into video or audio calls for me, with a low emphasis on chat-based interaction. Early on, I realized that the Debian Closure team interacts almost exclusively via, well, chat. And those two approaches are very different indeed. It has taken me some time to adjust, but I've improved greatly in this aspect as well. Finally, improving my time management skills has been also a key part of this process. Whereas I had already been working remotely for over a year and a half already, my day job is not so interaction dependent as this project, especially at the beginning. So it took me some time to adapt to this way of working and to plan my workload so I could use those waiting moments to advance in other parts of the project. Still a lot to improve here, but improving nevertheless. I first have to thank Upstream. More specifically, one of the upstream developers of the Clojure tools, Alex Miller. When I needed some information about what does a certain part of tools devs alpha do, he popped up a reply in a matter of hours. Plus, he has shown interest in the success of this project during our private interactions. Thank you for all that, Alex. Let's move on to the Debian Clojure team. First, Elana. I thank Elana for her initial openness when I first contacted her about this idea. It was her who initially contacted Louis-Philippe so he could become my mentor. I wouldn't have started to work on this project if it wasn't for her. Plus, she provided quite a piece of advice in more than one occasion. So, thank you very much for all that, Elana. I also thank Utkarsh, my co-mentor, for his overall technical advice, and a special mentor to his initial help to set up my Matrix client for OFTC chat. At that moment, it was him who took the time to help me in real time so I could solve that problem. So thank you very much for all that, Utkarsh. I finally have to thank Louis-Philippe, my mentor, for his patience guidance during the whole process. His dedication and hard work has been instrumental for my progress. And a special mention for his tolerance with respect to some unforeseen personal circumstances I had to endure during the first weeks. When one is playing the newbie, times abound when one depends on other people's feedback. And Debian is made of volunteers who have a life outside it. Every time I asked, Louis-Philippe was there. I wouldn't have gotten here if it wasn't for him. So thank you so much for all that, Louis-Philippe. I would like to close this talk with a reflection. I have been using Debian for many years now, and I had been looking for a way to contribute back to the project for some time already. I even did some work on a non-packaging Debian project. That being said, I never managed to deliver much really. So, the very existence of outreach programs as this one is, in my humble opinion, crucial. In my case, the funding I got through the GSOC program was instrumental in being able to allocate time for this endeavor and to finally get started contributing to Debian. Plus, it has had a very positive impact on me, in many ways, some of which I am only starting to discover now that the project is ending. When I put things into perspective, this project is very important for me. Actually, it is nothing but the first step within a long-term journey, becoming a Debian member. Hopefully, I would like to be able to apply for Debian membership by the end of this year. Thank you very much for your time. I look forward to hearing or reading your questions. So until then.
Hello to lovely audience of DebConf 2021. My name is Pavit Kaur and I'm here to present my Google Summer of Code project with Debian, which is incremental improvements to Debian CI platform. And for this project, I got the opportunity to be mentored by two amazing developers of Debian community, Antonio Tercero and Paul Gevers. So before moving on to my project details, a bit about me. I'm a third year undergraduate student pursuing Bachelor of Computer Science and Engineering in India. It's my first time working in open source. I started my open source journey with Debian in March 2021 with DebCI project itself. You can find me on IRC by my handle Pavit. Now, since my project concerns DebCI, a little introduction to it. DebCI coordinates the execution of automated tests against the packages in Debian system. And as of today, it controls the migration of packages from unstable to testing. It has a web platform, ci.debian.net, where all the test results are published. It provides package maintainers both with API as well as a self-service section, which is a GUI, to request tests and check out their test history. Now for my GSOC project, I'm working on to add 2 improvements to DebCI. First one is migrating the logins to Salsa. Originally, DebCI uses Debian SSO client certificates for login, but since that was deprecated, it calls for migration. Another one is enabling the support for private tests. Currently, any test that gets executed from DebCI, either through API or self-service section, is public in nature and its results get published on the platform. By enabling the support for private tests, testing of security updates could be implemented so that the security problem is publicized only after a fix for it is made available. Work done so far. My first task of migrating the logins to Salsa is completed. It has been implemented using Omniauth, a Ruby authentication framework, and it's part of DebCI 3.1 release. So now users could log in into their accounts on DebCI using their Debian Salsa accounts, and the usernames have been updated to their Debian Salsa usernames. And since Debian Salsa give the liberty to users to change their usernames whenever, their usernames would also be updated on DebCI platform as well, so that user does not lose its test history. Another thing is that now users don't have to worry about their expiry of client certificates. And when this release happened, I remember Paul mentioning on IRC that now he could re-trigger the test through mobile phone. So that's another plus. Enabling the support for private test. This task is in progress and most of it is implemented, which I would like to show you guys. So as part of the task of enabling private test, APIs has been updated to add new 2 keys to the JSON test object. One is private, through which user could specify whether the test needs to be private or not. And another is extra app sources, through which users could specify the repositories from which the packages need to be taken for private test. Similar thing is done for our self-service section as well, in which the request test form now contains 2 new fields. One is the private field and another is extra app sources. Updates has been done to the job history page as well, where now it contains the visibility column, which specifies that the test requested was private or public, and the visibility filter as well to filter out the private and public test. Now, before this update, retry feature was only available within the package history page, which is accessible from home. But that leads to a limitation for us that the private test would never be able to re-trigger, since they are accessible only from the job history of the user and only when the user is assessing its own job history. So for a solution to that, retry feature is added within self-service section as well. Now coming to the last part, that is publishing the private test when they are ready to be shown to public. That could be done by selecting the jobs here, either by select all by or by selecting individually. The test could be published through this page. So that's all as part of this task. The last merge request is for this job history page, which is still under review from the mentors. And after that, this task is completed. As for my next steps, I would be trying to solve more issues within DebCI or exploring more within the Debian community. Now coming to my experience and learnings with Debian, it has been an amazing journey. Both my mentors, Antonio and Paul, have been super supportive throughout it. They were always just a message away if I get stuck on something. And I learned so many new things. One is understanding the importance of writing tests in project, then good coding practices, which I came to know every time Antonio review my merge request. There were other things as well, that I set up my own blog post because of this opportunity and wrote of my first ever tutorial article also. I learned how Debian as a community whole works. My weekly meet calls were full of learning and fun, and which is one thing I'm going to miss after Google Summer of Code period is over. I want to contribute to Debian even after this period gets over. So yeah, it has been great. Thank you. That's all from my side. These are some of the links where you can find DebCI and you can find more about me. Thank you.
Hello everyone, my name is Shruthi Sridhar, and I will be presenting my Google Summer of Code project at Debian Med today. So my project was quality assurance and continuous integration for applications in life science and medicine. A little bit about me. I'm currently an undergraduate student at BITS Pilani, Goa. I'm a dual degree student, so I've gotten my BE in chemical engineering and a master's in biological sciences. And I'm currently pursuing my master's thesis at the National University of Singapore. So a little bit about the project. So my project is, as I mentioned before, quality assurance and continuous integrations, particularly for Debian Med life science packages. So these packages require auto package tests. So this would ensure that they give reproducible results on every installation. So in order to write these tests, you would have to have knowledge not only about the packaging workflow, but also about the tasks that the packages is trying to accomplish. And this was a nice blend of both my degrees, and it gave me a nice niche to work with. So the work done so far, there was auto package tests, quality assurance, and uncovering bugs and fixing them. And I worked on 25 packages since joining Debian Med. So the first challenge it was in itself understanding the packaging workflow, being quite new to open source software. But what was more challenging was finding the documentation and examples for the packages that we're writing tests for. Authors don't always have the best documentation, so sometimes just understanding the problem that a package is trying to solve is a challenge in itself. And next, in order to write auto package tests, I had to understand the most common use cases for a package, since that is the bare minimum of what auto package tests should ensure. And then the test had to be sensible and reproducible. So the output could be compared with a reference to make sure that the package was in fact working correctly. It's been a wonderful experience so far. The learning curve is quite steep since I'd never really used Linux commands beyond apt-get install before. But coming from there to being able to actually contribute to software that other people will use definitely feels really amazing. It was an excellent project to get familiar with software at scale and with various aspects of biology as well. Since each package is trying to address something different, I was constantly being challenged and also expanding my knowledge of in the field of biology. Debian is an amazing and a great place to be, and the Debian Med team even more so. The team has always been really helpful, especially my mentors. They were always approachable, just a text away. So overall, this has been a great starting point for open source contribution, and I really look forward to contributing in the future as well. And with that, I would like to thank Debian for this opportunity and my mentors for an amazing experience. Thank you.
Now,
So thank you all for the videos and your contribution the to Debian. And yeah, I don't see questions on the pad. I think we can skip on that. But I would like to thank each one of you for your interest in Debian and being part of GSOC and contributing. And we hope to uh, have you all staying back even after GSOC and eventually become DDs and part of the whole Debian family